Hi, everyone. Welcome to our session, Transforming Manufacturing, Energy and Utilities Industry with Azure Stream Analytics. I'm Jean-Sébastien Brunner, Principal Program Manager in the Azure Stream Analytics team.
And I'm Greg Floyd. I'm an enterprise architect with Southern Company.
So first, as the agenda of this session, I will show a high-level introduction of Azure Stream Analytics. And after, we'll talk about advanced analytics, geospatial, machine learning, edge analytics, and how to use custom code in streaming pipeline. And then Greg will show how they use stream analytics in the Southern Company. So just before starting, just a quick poll. Who already used stream analytics in the room? Quite a few people. So I hope I will not repeat too much things you already know. I only focus on the new things. But I will also show like high-level introduction just to be sure everyone understands the product. So the first question is, why do you need Azure Stream Analytics? And the answer is when you need to unlock real-time insights and when the time to insight is critical. For example, if you want to detect fraud, you need something that is about 90 milliseconds. You don't want people to swipe the credit card and to start to walk out of the shop with the goods. You want to detect that at the transaction, not in a nightly batch. Also in cross-sell, upsell, when you load a web page, you want to be very fast, about 120 milliseconds, to show this cross-sell in the page. You also, in manufacturing, you want to detect anomalies, stop an engine when it overheats. So it's usually about a few seconds. And in retail, if you want to adapt and react to competitor price change, you only have a few minutes, especially in the world of online retail. And here are a few examples, but I can give more examples of industries. Real-time fraud detection, talk about it, stream ETL, predictive maintenance, log analytics, fleet monitoring with geospatial, healthcare, smart grid and utilities, or real-time marketing. And basically, anytime you have data in motion and you want to take fast decisions, you can use streaming analytics. So I want to show you just a few customers with stream analytics. We have thousands of customers, just give a few examples here, and show some of the use case before drilling in the product. So the first use case, and we will talk about it with Greg a little later, is the Southern Company, and how they use geospatial for fleet management. For geospatial, we also work with NASCAR, so they were also one of the first users of the geospatial function in Azure Stream Analytics. So they monitor in real time the race and can also replay it afterwards. We work, oops, sorry for the layout. So we work also with Sky Alert. Sky Alert detects earthquake up to 40 seconds faster than the government system. It's backed up by Azure and Azure Stream Analytics. In utilities, we also work with TransAlta, so they use Stream Analytics for maintenance and remote monitoring of wind farms. And why all these companies use Stream Analytics? So here I have five main points, and I will drill down in each of them in the following slide. So the first reason is programmer productivity. We have a simple declarative SQL language, and I will show about it just after. And basically, if you know SQL, you can start in a few minutes to create a streaming pipeline. Also, it's very easy to get started. You can connect to and from other Azure services from the portal, from the API. It just takes a few minutes to make an end-to-end pipeline. It's fully managed, serverless. We are talking about job, not cluster, so there's no infrastructure to maintain, no OS update. Everything is done for you. You just add your logic, and you focus on your business, not the infrastructure. The next one is low TCO, total cost of ownership. Basically, you start to pay 11 cents an hour, and you can scale if you need to scale. If you don't need any computing, you can just stop it. You are not charged anymore. When you need more, you just can scale out and take all the power of Azure. And the last one is mission-critical reliability. Enterprise-grade SLA. I will talk a little more about that, but we have the best SLA for the streaming service today. So I mentioned the SQL language. So if you are familiar with SQL, you'll recognize it. So select from where, like all the SQL things, except we extended it with some windowing function. And I can use a laser here. So to have the concept of time windows, and we have some temporal operator here, and also geospatial function. So by combining time windows, geospatial function to SQL language, you can express very complex analytics in a simple SQL. And also it integrates with the tool you are using today. So we have a plugin for Visual Studio. So you can actually develop from Visual Studio, and we will have some demo later about that, and actually submit your job to the cloud. You can develop completely offline, and when you're ready, you can test it, and when you're ready, you can submit to the job. And you can also integrate with source control and with all your current tool. So I mentioned it's very easy to integrate with other services. Here, a canonical diagram. So Streamlabs is in the middle here, and our main point of contact for ingress are Event Hub, IoT Hub, and blobs. And you can stream a lot of data, millions of events per second to Stream Analytics, and put your SQL here, combine with machine learning if needed. And after, for hot pass analytics, you can actually have real-time dashboarding. We'll show that later. Trigger some action using Azure function, service bus, or do long-term archiving using SQL Server, SQL DW, Cosmos DB. So we have about 15 adapters, and we continuously add new connections. The interesting things here is not only we run in the cloud, but last November we announced we can take a Streamlabs job, run it in Docker on the edge. So we'll talk a little more about that later. So we have global availability. We are in 26 regions in the world. So basically, whenever you have IoT Hub, Event Hub, you will have Stream Analytics co-located. And you can basically run closer to your IoT device, closer to your infrastructure already there in Azure. In terms of SLA, so I want to mention we have 99.9% availability at the minute level. So if you look at our competitor, no one is offering a managed streaming service at this level. And in terms of streaming, that's very important because you don't want first to lose any events. And we guarantee at least one delivery. We never lose any event. And we make sure that we give you this availability. And ASA is based on Trill. So Trill is a Microsoft research project. It means trillion of events per day. So this is a super efficient in-memory engine. Actually, we release it as a free library for non-commercial use if you want to use it. And we package it in this super efficient way to create Stream Analytics. So it's 2 to 4 orders of magnitude faster than any other engine on the market. And this technology is already used to run some of the largest streaming pipeline you can imagine. We are running, for example, the Bing ads monetization pipeline. So it's several billion of dollars every year. Every time you basically have 1 second of delay, you are losing $200. So you can imagine the scale. Same with Office 365. All the telemetry and the scale. And this scale is managed with the same technology. So then I want to talk a little about time windows. So how do we do it in Stream Analytics? So that's one of the very important concepts we have, is we want to make very easy to manage these time windows. So we have few flavor of windows. I will start by the tumbling windows. You can just imagine the windows just tumbling 10 seconds after 10 seconds here. And the way you use it in SQL is just to use the group by operator. So sorry, the group by here. So you say, I want to use something on a tumbling windows of 10 seconds. I just use group by. And after, I use some aggregate. Here, it's very simple. It's just a count. You can do average, but you can also do some more complex things. So you can see how easy and readable it is. If you have to develop this code by yourself using C# and something else, it should start to be a little more complicated. But we have other kind of windows. So hopping windows, so that's very similar, but we have some overlap between them. Sliding windows, this one is very interesting because they actually trigger whenever an event enters the system. So they are event-based, but they still have a fixed duration. But again, very simple. You can see we use a group by on a sliding window. You can actually also put some filter here. And every time an event enters this system, we evaluate the last 10 seconds and output your aggregate. And actually, yesterday, we announced a new type of windows, the session windows. So this one in preview. And that's the first time in Stream Analytics we actually offer windows of variable duration. So it's very interesting for clickstream analytics, retail, manufacturing, whenever you want to detect a pattern of events that come together, and you can group them automatically. So the way it works is you define the session time, and you also put you define the minimum between two sessions and the maximum length of a window. So basically, you can say, give me every session that are at least separated by 5 minutes, but no more than 10 minutes in this example. And of course, you can use the full Windows length. In Streamaletics, we support from 1 microsecond to 7 days. So you can imagine all the scenarios between them. So real time to 7 days, basically. And this is in preview today, available for everyone. It's already documented. So if you have any feedback, anything, you can contact us. I will have the email for the team in the last slide. But in terms of time management, we have a lot of other features out of the box. Because when you try to implement this kind of thing by yourself, you will realize there's a lot of different edge cases. So the first thing is we enable you to select application time, which is very important in IoT scenarios, or ingest time. And I will show it in a couple of seconds why application time or device time is so important. You can also manage out-of-order events. So when you have some delay between your events, different devices don't go at the same speed when they talk to the cloud, so you can just reorder automatically. You can also do some join, and if you have several streams of data, you join them on a temporal basis. You can join streaming data with what we call reference data at rest to get some mapping with actual data you already have in your database. And we do adaptive micro-batching. So we adapt on the speed of the events. If you start to have very, very high throughput, we will adjust. If you start to slow down, we will adjust. So that is very interesting because you can control the cost to your outputs. So we don't just completely, I mean, for one transaction in input, we don't have one transaction in output. So if you're looking at, for example, ADLS or other output like this, you may have a cost by transaction, but we manage that automatically to minimize the latency and the price. And a new feature we announced recently, we manage streams with multiple timelines, and I will just show it in a few seconds. I just want to show a few things about time management. So actually I had an animation, but it seems it's not running here. So you'll have to follow me. So basically, in terms of time management, everybody thinks about the ideal case. OK, all the devices have the same time, the clocks are completely aligned, so that's what I show here. And all the data goes to the cloud with the same delay. Of course, that never happens. But we make sure you are covered when you use Streamaletics. So if you, for example, want to run an alert when you have 2 events or 2 anomalies in less than 5 minutes at the device level, that's the query you will need. Again, very readable. You can group by, and you put a filter on the count. And of course, your data arrive in the cloud. Let's say there's a little delay. After these 5 seconds, the alert is triggered. You are just delayed by the time between your device and the cloud. Looks good, right? But then in the real case, we have clock skew. All the devices have different time. If you look here, basically like device 1 and device 2, they have more than 10 seconds difference. And also you may even have transmission delays that are different between each device. So for simplicity, I will just show the different clocks here and not talk about the different delays to go to the cloud. But you can already see, like, if you need to reorder or wait for all the events to go to have the data to the cloud, you actually add some delay for the outputs for the alerts. And now instead of alerting 1 second later, I'm actually alerting at least 10 seconds later because I have to wait for the latest of the device. So this is interesting because at least I can combine all the data from the device and make some alerts or some rules at the global level. But at the individual device level, this is kind of costly because I have to delay everything. So we recently introduced what we call substreams. And the way it works is basically telling the system, I will look individually at every single streams. And it's still one job, and I only have one additional keyword over device ID, But under the cover, it actually parallelizes all the streamline and look independently at every device. It still looks like one job, but actually, if you have 1,000 devices, there's kind of 1,000 jobs running parallel for you, just in one keyword. And it's very useful because now I don't have to wait for other device. And when you think about connected car or like wind farms, they're not really connected to each other. So if I have one alert in one, I don't need to wait for the other ones to send the data to the cloud. So it's very useful to remove any delay for individual device. But if you need this global insight by combining data between all the different devices, you need to use the previous pattern without the over device ID. So it's a choice we give you, and depending on the scenario, you will see, oh, I don't need to combine all the data. Let's use the substream. I need to combine the data. I can remove the substream. And this is also available today. You can find in the documentation. It's documented in the timestamp, basically timestamp over. So I mentioned a few of them, but I just wanted to recap what we did since last year, since last build. So in terms of language, we did the first version of built-in anomaly detection. We added compatibility level in January and fixed few old bugs that were there for a very long time. Not really bug, but kind of asked, but we couldn't change them because we don't want to break any job. Basically, when you are running, you run 24/7, and we don't want to make any breaking change and change the behavior. So we introduced this compatibility level to be able to do these kind of things. We introduced substreams. I talk about it. In terms of input and output, we added compression support for input. So you can use gzip or deflate, for example, for JSON or CSVs. We added output to Azure functions. And we added the support to Power BI embedded, in addition to the Power BI streaming dataset we added last year. Also, we announced Stream Analytics on IoT Edge. We will talk a little more about that. And a few new data centers, UK West, Canada East, and Canada Central. And yesterday, I said today, but actually we announced it yesterday at Build, a few new things. So the session window I just mentioned. And we have a few things in private preview, and I have an URL here to apply. C# custom code available on IoT Edge. I will show a demo later. New built-in anomaly detection function. So we extended the previous preview with new functions. I will show a demo about it. And we now support also partitioning blob output by user-defined key. And again, there's a URL, and I will recap the URL at the end if you want to access these previews. And one interesting thing with the preview is it's very high-touch preview. You can ask questions to the team. You can influence the design. We can talk about your scenario. So don't hesitate. It's very interesting usually to work directly with customers on the scenarios. I want to talk about advanced analytics now. So I will start by Edge. And after, I will talk about Azure geospatial function, machine learning function, and custom code. So let's start by Edge. So I don't know how many people went to the IoT station, so all the drones, so it's very exciting. And actually, ASA, Stream Analytics, was one of the first services available on IoT Edge. And the things I mentioned before, all this easy to start SQL and all this easy connection with other services in the cloud are now available on the Edge. So the way it works is you go to the portal, you create a new job, and instead of cloud, you just say, I want an Edge job. It creates basically a Docker image, and after you go to the portal, IoT Hub portal, and you can deploy on device. You can deploy to one device, you can deploy to 10,000 devices at the same process, the same number of clicks. Of course, you can use the API and everything. And that's just like a canonical example here. We will control this job from the cloud, and you can send remotely the update later. But why using ASA on Edge? So there's a few use cases. I think the first one is low latency command and control, especially in manufacturing, utilities. So if you want to react in real time and don't have time to send the data to the cloud just to have some alert, and if you have some anomaly like overheating, over vibration, and you need to stop the machine, you really want to do it close to the machine, and you want also to act on that machine. So by decreasing this whole end-to-end, you can have a very efficient pipeline. also in case of limited connectivity to the cloud. You can be on an offshore rig, on a boat, on a connected car. You don't want your analytics, your alerting to stop whenever you go to a tunnel or offline. So you want this analytics to continue wherever you are. Similarly, if you are on an offshore rig on a boat, you probably don't have like a 5G connection. So in terms of limited bandwidth, you need to aggregate, filter, and only send the right information to the cloud. Probably not all the noise. So you can do that with stream analytics. And when you think about connected car, for example, of manufacturing robots, it's about like at least 10 megabytes per second. So just the cost of this transmission could be a lot for some scenarios. And the last one, but not the least, especially with GDPR and all the requirements, is compliance. Basically, with stream analytics, you can actually anonymize or aggregate the data before sending it to the cloud. So you can remove any personal identification or aggregate on many users. So basically, you are not sending any PI to the cloud. And all of this can be used with the SQL language I showed before and all the different things we show for stream analytics. And the big advantage is really you have the same language for both cloud and edge job. And if you look at the market, there's already a lot of people on the edge analytics, but it's very rare that you can use the same language and decide, oh, I can run that to the cloud today, but maybe if I have more throughput, I will change it and run that to the edge later. It's the same language, the same workflow, and the integration is very easy. So it's cross-platform. So we run on Docker container. It can run on Linux, on Windows. It can run on Intel or ARM CPUs. So basically, you can take Azure Stream Analytics wherever you want. And we leverage Azure IoT Edge for security, deployment, and manageability. So all the things you saw yesterday in the keynote, or all the things about IoT Edge, basically, you can use them here for Stream Analytics. And this is like a reference architecture. It's like you can use Azure Stream Analytics. You can use Azure Functions, the cognitive services that were announced yesterday. And you can also extend that with custom code, for example, to connect to some specific robot or something like this. Everything run on your device, securely managed from the cloud. And you can deploy and manage that at scale, manage 1,000, 1 million devices directly from the cloud. It's a complement to what we do in the cloud. So usual pattern is in the cloud, you do, for example, for machine learning, like the training, the big data analytics, and in the edge, you do more the local analytics and the scoring, for example, for ML. So then I want to talk about geospatial. So that's something we did last year. And we start to have a lot of traction. And Greg will talk a little more about how it can be used in your life. But you can do like asset tracking, fleet management, geofencing, and you can imagine all the scenarios. And when you talk about geospatial, we talk about like a map, like a kilometer, a mile, or something like this. But we can also talk about a meter, a centimeter, a foot. I'm using all the different units because I'm from France, so it's more, I'm using more the metric system, but I want to be sure everyone can use it. So basically, whatever your unit, if you are in manufacturing, you may want to look on a circuit board. We can use some millimeter or centimeter. You can use some large-scale things for connected car. You can use any geospatial data here. And we have some manufacturing customers who actually use geospatial to see the distance on circuit board and things like this to detect anomalies. So geospatial is a very interesting thing because it can be applied at different levels. And the way it can be used is very easy. Again, we extended the SQL language with some functions here. So you can create the data and use, for example, ST-distance for distance and call it directly from SQL. And you can see how easy it is. Just to trigger an alert when your car is less than 50 kilometers from a gas station, it's just this 3 lines of query. And the query will be there, standing 24/7. Whenever the conditions are met, it just triggers whatever you want. So it's going to be easier. And we're just using the standard for GPS, so WGS84. So it's very easy, GeoJSON, and any geospatial data can be used in Stream Analytics. So we'll talk a little more in the use case later. So after, we have some integration with machine learning. We already had integration with Azure machine learning before. And now we have the anomaly detection functions. So last year, we had only one function. We are just adding 5 functions, private preview. Again, that was announced yesterday. You can join the preview. And the few functions we have are all callable with SQL, and I will show that in a few seconds. And we can detect change of level, dip and spike detection, or positive and negative trend. So I think that, so I have some illustration here, but I think that's time for a little demo. Yeah, this one. So basically what I have here, I have a job running for anomaly detection. So I will just show the job, just to show how easy it is to create this kind of job. And so my computer was idle for a few minutes. Let's hope everything is still running. Sometimes the connectivity in conference is a little slow. Let me just refresh. OK, so I have a job running here. I just want to show the job first. So that's the Azure portal. I will open Azure Stream Analytics here. And I'm not sure why the job is not responding. Oh, it's here. I just have some trouble to click. So basically, that's my job here. I have one input from IoT Hub, and I output to Power BI, and I can store it as well. But let's look at the query first, just to see how to detect anomalies. So it's a little gray out because it's running, so that means you cannot edit when it runs, but that's OK. But here, you see this first block of code, or SQL code. That's basically how I detect two kinds of anomalies. So basically, with these two lines of code, no training necessary. This is a pre-trained model we offer in the SQL language. I detect the spike anomaly, and I detect the level change. And for demo purposes, I do the automatic training on 30 seconds. So it's very fast running. In real life, you may have something longer depending on your scenarios. So that basically, just because it's running, it's doing some weird stuff. But let's ignore that. So basically, that's my anomaly detection. And after I just format it to send it nicely to Power BI, I just make some nice naming, and I calculate the time between now and the last time I have an anomaly. I can actually upload a sample too if I want to verify the query. I have a sample here. So basically, we have a full authoring experience in the portal, as well as Visual Studio, so we can author, we can test the query. What happened? It's interesting. Like, you can do the demo all morning at the booth, it works, and whenever you go to a session, there's something weird. Test. Let me try again. It's here. I can try, but oops. I think something didn't work when I went idle. That's OK. Sorry for that. Wouldn't be a live demo if everything was right. Huh? So upload sample. OK, here you go. And basically, so we have all authoring experience. We sent syntax highlighting and error highlighting in the portal, and a test in the browser here. So basically, you can author here or in Visual Studio. And sorry, the resolution is not ideal, but basically, that helps you to author the query in the portal. And basically, after I take that, I have some simulator here that simulates some data. It's sent from my laptop to the cloud, and I visualize in Power BI. And what I'm showing here is like we have some random temperature. So it was running for a long time, so just need to update. We have some random temperature, you see, like with some oscillation here. And every 60 seconds, I generate like a change of level. And without having to specify how big is the change, what I'm expected, the model just trains automatically itself over 30 seconds of data. And then whenever there's a change, actually trigger an anomaly. So like the black one is that change anomaly. And I can see like the last anomaly was 50 seconds ago. I can also trigger a spike, for example. Let's do a spike right now. So I'm sending a spike from my laptop to IoT Hub. IoT Hub is processing Stream Analytics and send the data to Power BI. So the connection is a little slow, but I can see something already arrive here because the scale changed. And the anomaly is already detected here, as you can see. And 13 seconds ago, basically, I had a reset on my spike detection. And at some point, Power BI will see it, and I apologize for that. I think the network is pretty slow. Oh, it just appeared here. So that's the spike I generated, and you can see the anomaly. Again, one line of code for detecting spike, one line of code for detecting the change of level. So no need of data scientist. You can start right away in 5 minutes. Basically, I needed 30 minutes to do the whole end-to-end demo. So I see a question in the room.
Yes. Okay. So you said there was a preloaded model that you're using for this. Can you preload your own custom models to do anomaly detection?
A good question. So the question is, I said I have a preloaded model. Can we load a custom model? So the answer is yes or no. So yes, we have integration with Azure Machine Learning, the studio. And when you productize your model using a REST function, REST API, we can actually call out to this model. So that's the first integration. If you really want to run your custom code, so export a R or Python model, this is not yet available. So I will talk about the C# integration that we are adding on the edge today. So that's available, but we are working on different language later, so you can integrate the models you want. So that's for the anomaly detection demo. Any other question on this demo? So let me go back to the presentation then. Thank you. So that's a good transition actually for custom code. So last year, we added the JavaScript support for UDF, so user-defined functions. That actually are stateless functions, so you can do string parsing, manipulation, or array operation, regular expression, mass operation, for example. Basically, you can just run JavaScript. And we also have UDA, which are user-defined aggregates. This one are stateful, so you can actually run your custom aggregate. Instead of having average or count, you can have a weighted average, a cumulative density, array accumulation. That's basically your own count of something over the time windows. So you have full flexibility to define your own aggregates. So that was last year. We have a little more of 1 year feedback, very popular features. But we realized that a lot of our customers wanted to have C#. So yesterday, we announced the support for C# custom code. It's in private preview. And today, we are running on Edge only, and we will open later for the cloud. But basically, what does it mean? It means you can run your own DLL, your own code in your streaming pipeline. Everything will run in memory, close to the streaming pipeline. No need to call different modules, having some I/O. It's much more efficient. So you can reuse project and library you have, and I will show in the demo. And of course, you can use Visual Studio. And if you want to join the preview, same URL as before for the previews. But I can show you how it looks today. So if we can switch to the laptop again. Thank you. So I showed the portal before. Now I'm showing the authoring experience in Visual Studio. So we have very similar functions, but here you can work completely offline. And when you're ready, actually, you can take your job and publish to Azure. So in this example, I want to show you, so it's an example in the manufacturing world. Imagine you have some robots, and the manufacturer, the robot manufacturer, basically have some DLL or something to understand the message. So that's an example of message sent by the robots. So that's something you can read in the payload directly, like the ID, some vibration, X, Y, Z. But there's also some encoded data. And the manufacturer will give you a DLL, said, if you want to understand this, I have all the DLL because it's very complex. And basically, you can just run it here and understand it after using the DLL. So what we did is to actually create a C# class here. And I don't know if it's big enough, but I can zoom it if needed. But basically, we have a C# class that references basically the DLL given by the robot manufacturer. So imagine here it's count of the robots. But they have all the logic to decode, and after all the kind of their own business logic to decode that kind of very low-level code to meaningful insight. And then they give a user manual, and they tell you from that you can do, for example, understand if you need to fix the angle on your robot arm. Or they can give you some API so you can adjust it when you find an anomaly and tell you if it's normal. You can also have an insight if the temperature is normal or if you need to do something else. They give you from this payload, they will tell you, oh, the battery is not charging anymore. It's charging too slow. You need to actually call the maintenance. And in the manufacturing world, it's very typical that we have a third party giving this kind of insight, and so you have to integrate in your streaming pipeline. And we heard a lot this kind of scenario from customer. So that's why we now integrate C# DLL and your own code directly in the streaming pipeline. So here's the example. You can see like very easy to read the DLL and use it, but even easier to use in Stream Analytics. You add it to that project. It's just a reference to my Streaming Analytics project here. And after in the SQL script, I call it by using UDF dot the name of my function. Again, very easy to integrate with SQL. I send all the parameters here, and after I show them. But not only I can define here, I can also test locally. I don't even need a connection to the cloud. So I can just run it. It generates the file offline, and after I can see the result here. And I can see one of the robots. So from my payload sample I had before, I can see, for example, this one is battery service. This one is arm adjustment. And I think there's few other needs, some maintenance here, battery service. So just a simple example, how you reuse a DLL, or you create custom code and integrate very easily in the SQL pipeline. And again, you will save a lot of I/O and run everything in memory closer to your device. So that's basically it for this demo. And after, I will let Greg describe the use case with the Thousand company.
Thank you. Thank you. So a little bit about Southern Company, my employer. Southern Company is one of the largest energy companies in the United States. It has over 9 million customers across 19 different states. We have 11 regulated utilities. We're going to talk about Georgia Power as one of our electric utilities. And it's comprised of electric, natural gas, and other companies, including a telecom company. We have 37,000 employees. I'm one of them, and I'm out of Atlanta. You probably guessed that. So today I'm here to talk about how we're using Azure and Stream Analytics for asset, vehicle, and crew location tracking. An example of an asset is bucket backhoes, trailers, containers, portable substations, and vehicles that we track, mostly bucket trucks, as you would associate with electric companies, as well as line trucks and other fleet vehicles. We also tag those vehicles and equipment with crews, both internally and externally, as is the case when other external utilities come to assist us in power restoration after a storm, like Hurricane Irma last year. So the main focus of my talk today will be to talk about how we use location tracking for these various entities to restore power. But there's other use cases as well. We also use this data in other ways, and we'll see later how we do that, to recover items that are stolen, to promote safe driving, and to protect our workers who may be in remote locations. So the point of this Azure Streaming Analytics use case is really to talk about how we as Southern Company have used the cloud and streaming analytics to obtain business value quickly. So I'm going to talk a little bit about the solution architecture. The solution architecture is a cloud-based architecture. This is a subset. On the right side, you see all the services that comprise the solution. There's two basic inputs, the basic device and the advanced device. The basic device is your simple tracker that will communicate over UDP or TCP protocols. Those basic devices communicate into a collection of cloud services grouped into listener services, parser services, and vendor forwarding services. Most time, basic devices are provisioned by vendors. So when that telemetry comes in from the basic devices, a listener picks it up, places it on an event hub, and then a vendor forwarding service parses that information, publishes it to the IoT hub, and sends it on to the IoT vendor. The point of this solution was really to support multiple vendors and multiple devices and carriers. And what we've built is a framework so that each business unit could create their own use case as we described above. So advanced devices are actually iPhones or rugged laptops that sit in the truck. They can communicate directly to the IoT hub. All of this data from both basic and advanced devices flow in. The cloud services that parse the basic devices canonicalize the message, drop it into the IoT hub. Advanced devices publish directly authenticated messages to the IoT hub, and then begins our Azure streaming analytics. What I show is the sample we'll look at today is location tracking, where a streaming analytics job picks up these messages, reduces the set so that on-premise systems can absorb this type of data, and then publishes it to Event Hub where it's brought back on-premise into our outage management system. Other use cases could continue. For example, preventive maintenance, looking for alerts from the vehicle that the oil needs changing, or safe driving, looking at the deceleration patterns of the driver. So we'll show you a little bit of the code. Let's see, 8. So in this example, I'm showing a solution that I built called Tracker, and you'll be able to download this. It's completely run locally, and what I've done is I've put some sample tracker messages from 2 different types of trackers. So the first tracker, the actual basic, these are both basic trackers. The message that comes in is in the body. That's the raw message. And then the parsers canonicalize that message and drop it into this JSON for the IoT. The vendor forwarder will get the raw message as it's received in the format that the vendor requires. And we're using enrichment to publish additional information into this message. For example, what is the device type? What kind of message is this? Is it a location, an alert? Is it a diagnostic? And so forth. So this is one of the examples. And here's another example of an encoded message that's coming from a different type of tracker. We support multiple types of trackers, and those are provided by different vendors. So we can host this framework for different vendors at the same time. And so what I've put together is a sample for a single device over a 24-hour period for different message types. And the purpose of this is to run through this streaming analytics job using a lot of the functions, geospatial functions and analytical functions, along with windowing functions, to reduce this to a manageable set so that our on-premise systems can consume these. In this particular example, this outage location tracking data is flowing into our outage management system. And so the job itself looks like this. And I'll step through it briefly. So the first thing we do is we retrieve the message from the streaming analytics in the IoT hub, and we look at the previous message that we heard from up to 4 hours ago. We filter out any messages without a valid GPS, and then we calculate the distance between the previous message and the current message. We do this because often GPS trackers bop around. The next thing we do is we determine whether this tracker that's sending the telemetry, is this an active tracker or an inactive tracker? If the business results are that if it's an active tracker, we'd like to see the data every 2 minutes. Inactive trackers, every 2 hours is fine. This is a vehicle and not an asset, although I will tell you that a lot of the data that actually comes into the system is more about the assets as well. So in this example, we're defining a parked device as one that has not moved more than 400 meters or a quarter of a mile in 2 hours. And it recognizes a 0 speed. And you say, well, why did you do it this way? Why didn't you just accept the speed and the movement from the actual device? The purpose of this was to support external crews where they may use an iPhone application or an application that pings its GPS. And then we can calculate whether it's moving or not. So basically, any device that can communicate its lat long or geo coordinates, we can actually use in this system, the simplest device to the most advanced. And so once we determine whether it's active or inactive based on those two conditions, we're using a tumbling window, as you see here. Then we collate the two sets together as parked and moving, and we grab the original information from the message that came into the streaming analytics. And then we insert it into the event hub. So if you go back to that first diagram, we move the data from streaming analytics into an event hub. And as subsequent use cases come along, like theft prevention, for instance, if a container door opens and it fires an alert and we know it's after hours, then we will have a new Azure Streaming Analytics solution looking at particular device types as well as an output sync. So I put this together so that you could actually see it and play with it, and certainly if you improve on it, let me know. So you can run the entire job locally, and what it's going to produce is a spreadsheet similar to this, a CSV similar to this. And you can see at the bottom what's highlighted in blue. Most of the tracker information that came in, there were 288 messages, and it reduced it down by 80% into 55 messages. And the key here is that that's a manageable set of data that we can bring into our on-premise systems. So you'll notice the ones in gray are actually when that vehicle was parked and there was no activity going on overnight. This helps considerably to bring the information in. The vendor forwarding for this particular device, the vendor actually gets every single message that comes in. So we actually play a man in the middle where we're brokering these messages to our outside systems and partners who are helping us with either lone worker safety or our telemetry vehicle tracking. Okay, so it's very important that no matter what kind of system you build, anytime you build an IoT system, that you have a dashboard with metrics and alerts. We built this dashboard. This represents a very blue sky day. We didn't have a lot of work going on. In the event of a storm, like in Hurricane Irma, you would quadruple this data, or even more. So as we thought about the solution, we built the solution fairly quickly, and we iterated over the design of the solution in small steps so that the business could see value right away. Instead of going with a vendor-based system and having to go back to them to export this data, we wanted to get a copy of this data. It's our data, and we wanted to analyze it. So that's why we built this system. And as we look towards how we would improve this system, we're doing it in 4 key areas. Let's see. So the first area is the basic device today communicates to cloud services. We want to remove that and take the listener and move that into containers. And we want to move the vendor forwarding and the parsing into functions. They still use the event hub for a pipeline processing. And if I can give you any advice, it would be as you build these solutions, build them in small, manageable components so that you can replace key components as better technologies come along. The other areas we're improving in is CosmoDB. We're looking at potentially storing for cold path analytics the data that comes in from the IoT hub, which also includes the raw message. And then at the bottom, you'll notice that we're looking at creating an edge gateway with IoT Edge, communicating back and forth with beacons. So why did Southern Company choose Azure and Stream Analytics? Again, the basic idea was we wanted to build a framework so that we could control the data. And as we came up with new business cases, we could build those business cases by our product groups, and they could implement them without IT support. So it's very easy. From a scalability perspective, this system was built to handle storm conditions in the cloud. If we had built this system on premise, as you know, we would have had to scale up and build that system to handle the max situation, which was not very feasible. As it stood, when we put this solution into the cloud, it was very quickly, we were able to scale 3 components to handle Hurricane Irma and watch the trucks moving around. And the actual outage management system that received the data was easily able to handle that amount of data because we weren't giving them 15-second data for every single device out there. Today, there's 1,400 devices with 3,000 more coming online soon. So from a scalability perspective, we found app insights, dashboarding, and alerting to be critical, and it helped us. From a developer productivity, it's SQL. We all know SQL as developers, and the business knows SQL, and they can easily create output sinks in SQL that manages their use case. It's quick to integrate data. In fact, we enrich data coming into the Stream Analytics job, and we can add more data sinks. And it's fail fast, so we can quickly prototype the system and try it out, and the business can as well. And finally, it was an extensible framework. Like I said, we componentized the pieces so that each one could be replaced and updated as necessary. It's easy to update the system, and additional use cases are quick to add. Thank you.
Oops. So you can actually see the whole case study online, so we have that described on the Azure website. And Greg, email if you have any question. You put the code on GitHub as well?
I did. So the code's available on GitHub. There's a link in the next slide. There you go. So you can...
Oh, it seems the slides were not updated. So we can add it in the session information in the slide we will share.
Yeah. And in this deck that you'll get, there's also an architecture reference, so you can see the whole architecture as it was conceived.
And for any questions, and subscribe to the previews as a link, you can contact the PM team for Stream Analytics. And don't hesitate to ask any question to Greg and me right now, so we can stay for Q&A, of course, and after the session if you want to chat. And I have to remind you also to fill the evaluation, and so you will be eligible for some prize. So any question from the rooms?
So when you showed your first 2 options there to begin with, where you have one where you were delayed and the other one where you could get it real time, but you get each. We actually need a situation, and this kind of moved us from Event Hub, where we want kind of a mix of the two, where we want to say, here's a calculation that's not final yet, right? Like here's the, but late data may come and change the calculation. So here's like a non-final version of the calculation, right? Do you have any kind of plans for something like that?
I see. So the question is, do we have any plans so we can have basically different steps, like non-final and final calculation? So we actually can have several steps using the with keyword. You can have independent blocks of analytics in the same query.
So this one in particular, like we can get data out of order up to 7 days. Right?
Oh, okay.
You don't want to delay by 7 days before you ever see the calculation.
Okay. So the out of order parameter is at the job level, so for every step in the same job. But then you can still use substream in one of the steps. So basically, you can have one step that go at the device level using the timestamp by, and other steps that just follow the regular out of order.
Okay.
So because you can control that substream with the timestamp keyword. So every time basically you have a new stream of data, you can choose whether you choose it at global level or like local level. And if you have a scenario, I will be, let me put the email again, I will be happy to help you to write the query based on the scenario. Any other question, feedback? feature you want to see next? We're actually in planning process for the next semester, so that's the best time of the year actually to request feature from all the Azure teams. So if no other question, I thank you for your time.
Thank you.
Bye.